These are lecture notes for Melham's Math 225, continuing on the last section, section 13.5. I've decided to throw out one problem. It's too long. So we're over here at 13.5. I did a couple of problems already. Skip problem 15 also. It's just too long. Okay, so I was going to do everything up to 15. So 17 and 19 I was going to save for next time. Okay, so 13.5, page 958. Question 5, x to the fourth plus 10x cubed plus 38x squared plus 66x plus 45 equals 0. They tell me x equals -2 plus I is one root, automatically in red. So this was given, red is new. X equals -2 minus I is also a root. So that means in terms of finding a factor, remember it's x minus each of these. So x minus parentheses -2 plus I, x minus parentheses -2 minus I. Distribute, that's x plus 2 minus I, x plus 2 plus I. That looks like a minus b, a plus b, which is a squared minus b squared. So x plus 2 squared minus I squared. Negative I squared is plus 1, it's -1. X squared plus 4x plus 4 plus 1, x squared plus 4x plus 5. Okay, so I can divide out x squared plus 4x plus 5 from the original polynomial. And here it is. That's supposed to be a 9. I messed up. That's 9. That's a 33. That's a 9. That's a 9. Okay, so long division. Remember, you cannot do synthetic division unless you have linear factors. This is not linear. It's quadratic. So we have to do long division. Okay, so what do I multiply x squared by to get x to the fourth? X squared. Now x squared times this whole thing. X to the fourth plus 4x cubed plus 5x squared. Subtract. That's nothing. 10x cubed minus 4x cubed is 6x cubed. That's 38x squared minus 5x squared is 33x squared. Bring down to 66x. Do it again. How many times is x squared going to 6x cubed? 6x. Multiply 6x times this whole thing. 6x squared plus 6x cubed plus 24x squared plus 30x. Subtract. Cancels out. 9x squared plus 36x, bring down to 45. That's a 9. X squared into 9x squared is a plus 9. 9 times that whole thing is 9x squared plus 36x plus 45. If you can't read this, it matches that. So when you subtract it, 0. So the original polynomial is x squared plus 4x plus 5 times x squared plus 6x plus 9. This further factors into x plus 3 squared. Okay, so I have it completely factored. Fourth degree means there's 4 zeros and 4 factors. The 4 factors are, rewriting this as an original factor. So x plus 2 minus I, x plus 2 plus I. This comes out to be x plus 3 squared, which means the zeros are -2 plus or minus I and -3 of multiplicity 2. That's 1, 2. Remember, this is 2, -2 plus I, -2 minus I, and -3 twice for the 4 roots. Okay, problem 9, 4x to the fourth minus 32x cubed plus 81x squared minus 72x plus 162 equals 0. They tell me 4 plus radical 2i. So in red, that automatically means 4 minus radical 2i. If I multiply these two together, I'll get a quadratic. I start off with x to the fourth, so I'll be left with a quadratic, and after that I can use the quadratic formula or whatever. So factors are x minus all that, x minus parentheses 4 plus radical 2i, x minus parentheses 4 minus radical 2i. Distribute x minus 4 minus radical 2i, x minus 4 plus radical 2i. So again, that's x minus 4 squared minus root 2 times root 2 is 2i squared. -2i squared is plus 2. So square this, x squared minus 8x plus 16 plus 2. 8x squared minus 8x plus 18. So now I'll do long division of all that by x squared minus 8x plus 18. Okay, so first thing here, what do you multiply x squared by to get 4x to the fourth? 4x squared. Now 4x squared times this whole thing, 4x to the fourth minus 32x cubed plus 72x squared. Subtract, that cancels out. That cancels out. 81 minus 72 is 9. 9x squared, bring down the rest, minus 72x plus 162. How many times is x squared going to 9x squared plus 9? 9 times this whole thing is 9x squared minus 72x plus 162. Perfect. So I can write the original polynomial now as x squared minus 8x plus 18 times 4x squared plus 9. So I solve this, set that equal to 0, subtract 9 and divide 4, x squared equals -9/4. By the square root property, x is plus or minus the square root of -9/4. Take out the negative as an I, plus or minus I radical 9/4, plus or minus 3/2 I. So my 4 solutions are all complex. My factored polynomial is x minus 4 minus radical 2i, x minus 4 plus radical 2i, x plus 3/2 I, x minus 3/2 I. And here are the roots. Notice they're in conjugate pairs. 4 plus or minus 4 plus or minus radical 2i, and plus or minus 3/2 I. 4 solutions are all complex. Okay, and finally, number 13, 15x cubed minus 16x squared plus 9x minus 2 equals 0. X equals 1 plus radical 2i over 3. So that automatically gives me x equals 1 minus radical 2i over 3. So I get x minus each one, x minus 1/3 plus radical 2/3 I, x minus 1/3 minus radical 2/3 I. Distribute x minus 1/3 minus radical 2/3 I, x minus 1/3 plus radical 2/3 I. So that's x minus 1/3 squared. That is the same as that. So I square it, minus this thing squared. Radical 2/3 I squared is 2/9 I squared. That will become plus 2/9. Square this x squared minus 2/3 x plus 1/9 plus 2/9. 1/9 plus 2/9 is 3/9 or 1/3. So I have x squared minus 2/3 x plus 1/3. To make things nicer, multiply this polynomial by 3. Okay, that's going to be okay. That will get accounted for eventually over here. So I multiply by 3, I have 3x squared minus 2x plus 1. All right, so now I'll divide out 3x squared minus 2x plus 1 from the original polynomial of 15x cubed minus 16x squared plus 9x minus 2. Okay, so this into this, 3x squared into 15x cubed is 5x. Now 5x times this whole thing, 15x cubed minus 10x squared plus 5x. Subtract, that cancels out. Negative 16 minus a minus 10 plus 10, negative 6x squared. 9x minus 5x is 4x minus 2. Okay, how many times is 3x squared going to negative 6x squared? That's minus 2. And then it works out perfectly. Negative 2 times this whole thing is negative 6x squared plus 4x minus 2, so no remainder. So my original polynomial is 3x squared minus 2x plus 1 times 5x minus 2. You can double check by multiplying that all out. You'll see that you get this. Okay, so now fully factored, okay, I took out the 3. So 3x minus 1/3 minus square root of 2 over 3i, x minus 1/3 plus radical 2/3 I times 5x minus 2. And my zeros are 1 plus or minus radical 2i over 3 and 2/5. Right, so that should show you all the problems that are in this section, except for the last 2, and I'll save that for next time, 17 and 19. So next time, Thursday, I'll do 17, 19, take questions about the test, and then give you the quiz. Right, so that's it for the lecture for Wednesday, the 12th, for Math 225.